Okay, so this is problem 4 from chapter 11 of Giancoli 6th edition. So what they say is that there is a fisherman's scales that stretches by a certain amount, in my case 4 centimeters, when a fish, in my case 3.5 kilogram fish, hangs from it. Okay? So the idea is we have this scale. Here it is the scale. Once we put the fish on it, it stretches a little, right? By that certain amount that is given to us. So this amount in my case is 0.04 meters. Okay, they want to know what is the spring stiffness constant. We know that the scale is stretched and found a new equilibrium. Found a new equilibrium when the weight that was added to it, so it's the weight of the fish, was equilibrated, became equal to the force, the restoring force, no? The force that we get from Hooke's law, and this is Kx. Okay? So what we have is that Kx, and x is 0.04, is equal to m. M is the mass of the fish, in my case is 3.4 kilograms, multiplied by g. And from here we can get the spring stiffness constant. Okay, so part A is easy, and we go to part B. In part B, they say, what will be the amplitude and the frequency of vibration if this fish is pulled down? Okay, so it's pulled down by a certain amount, and then starts this vibration going up and down. So it's pulled down by this amount. In my case, this amount is 0.025 meters, 2.5 centimeters. So this amount that is pulled down is already the amplitude. So the amplitude is given to us. The amplitude is just this. And then comes the question about the frequency. Well, if you have such good memory, you can go straight for the equation that we found that connects period frequency with mass and the constant of the spring. This equation is period is equal to 2 pi square root of mk. Okay, and we also know that the period is 1 over frequency. From this equation you can get what the frequency is. But suppose you don't remember this equation. I don't memorize these equations, I always derive them. So how would you derive? Well, use conservation of energy. What we know is the maximum kinetic energy is equal to the maximum elastic potential energy. Okay? This is conservation of energy. And use also that analogy that we made between this simple harmonic motion done by a spring with the uniform circular motion. From that analogy, we said that the maximum speed is equal to 2 pi, the radius becomes the amplitude divided by the period. Combine these two equations, we can find this one here, the one for the period. So this should not be too hard. What we get combining these two equations, well, I can cancel these halves. I have that the maximum speed is equal to square root of k over m multiplied by a. So this is what I got from the top equation. And at the same time, I have that the maximum speed is 2 pi amplitude divided by the period. And from here, you can see the equation for the period showing up, right? So the period is 2 pi and square root of m divided by k. And this is the end of this problem.